Two extension cords are lying on a shelf at a store right now. Same length, same gauge printed on the jacket. Same molded plug, same 3 outlets, same holographic safety sticker. One costs $11, the other costs $1. We went through the Federal Recall Database, the Commission's rulemaking record, and the standard that governs every cord set sold in this country. And here is what separates them. Inside the cheap one, the conductor is aluminum with a thin copper cladding, about 61% of copper's ability to carry current, in a jacket rated as though it were copper. Run a space heater through that, and the arithmetic is not on your side. 642,000 of these were recalled in a single month in 2006. We are going to cover the substitute, the forged label, and what you can actually check. Two extension cords are lying on a shelf right now, side by side. Same length, same gauge printed on the jacket, same molded plug, same 3 outlets, same silver holographic sticker. One costs $11, the other costs $1. Cut them both open, and here is the difference. The expensive one is stranded copper all the way through. The cheap one has an aluminum core with a thin layer of copper bonded around the outside. In the trade, it is called copper-clad aluminum, or CCA. Now understand why that cladding exists. It is not there for conductivity. It is there because copper is what everyone expects to see. Strip the insulation from a copper-clad conductor, and the cut end is copper-colored. Solder it, crimp it, mold a plug onto it, and it behaves like copper at the connection. The metal doing the actual work is buried underneath. Aluminum is dramatically cheaper than copper, and it is dramatically lighter. Both of those are the point, which gives you the first thing you can check tonight with no tools. Pick up 2 cords of the same gauge and the same length and feel the difference. Copper is roughly 3 times denser than aluminum. A genuine copper cord has a heft the substitute cannot fake. Except sometimes it can. In the data cable trade, where this same substitution has been running for years, installers have found ballast added inside spools specifically to match the weight of all copper product. The counterfeiters know about the weight test. Every visible cue this product offers is the cue the substitute has learned to copy. And the one difference that cannot be copied is the one you cannot see what happens when you actually push current through it. Aluminum carries roughly 61% of the current copper does through the same cross-section. Put the other way around. Resistance in an aluminum conductor runs about 55% higher than copper at the same diameter. Now the arithmetic that turns that into a fire. Heat produced inside a wire rises with the current squared, multiplied by the resistance. Hold the current the same and raise the resistance, and the heat goes up in direct proportion. This is not an engineering opinion or a manufacturer's claim. It is a formula, and it does not negotiate. One point of fairness, because it matters. The copper skin on a clad conductor does carry current. It is not decorative. But at ordinary household frequency, current distributes through the entire cross-section of the wire rather than riding the surface, so the aluminum core is doing most of the work. The cladding helps at the terminals. It does not rescue the middle of the run. So where does this actually bite? A table lamp does not care. A phone charger does not care. Almost nothing you plug in casually will ever reveal the difference. A space heater will. So will a window air conditioner, a compressor starting under load, a shop vacuum, a portable induction burner, anything that pulls near the cord's rated amperage for a sustained period. Here is the sequence. The conductor warms. That warmth has nowhere to go because it is wrapped in insulation designed to hold heat away from you rather than release it. The insulation softens. Softened insulation is how a hot cord becomes a short circuit, usually behind furniture, usually while nobody is in the room. And note what did not happen in that sequence. Nobody overloaded anything. The cord failed while carrying exactly the load printed on its own jacket. That rating was calculated for copper. The cord is not copper, which raises the obvious question. How is any of this legal? It is not legal. It never has been. UL 817 is the safety standard for cord sets and power supply cords. By reference to UL 62, the standard covering flexible cords and cables, it requires that extension cords be made of annealed copper wire strands. Neither aluminum nor steel is an acceptable material for wire used in an extension cord. That requirement is not new, and it has not been relaxed. Copper was required then, copper is required now, which is the whole mechanism of this story. Because if a cord must be copper to be listed, then a cord that is not copper cannot arrive carrying an honest label. It has to arrive carrying a false one. And that is exactly what happened. The cords in the federal recall record were not sold as unlisted bargain products with a warning on the bag. They were sold with a silver holographic safety label attached, printed with a certification file number and a rating, 13 amps, 125 volts, 1625 watts. The labels were counterfeit. Now understand what that hologram is supposed to represent, because most people have never thought about it. A listed cord is one a laboratory has actively tried to destroy. The joint where the cord enters the plug is pulled under mechanical force. The insulation is tested for how it behaves in flame. The construction is examined component by component. And then the factory is audited on a continuing basis, so that the 10,000th cord off the line matches the one that passed. That is a serious, expensive, ongoing process. A holographic sticker is a piece of foil. The sticker was never the safety. The sticker is only a claim that the safety happened somewhere else, to somebody else's satisfaction, on a date nobody present can verify. And here is what that forgery bought, measured in units. In August of 2006, Dollar Tree stores recalled about 600,000 extension cords. The product was called the Power Extension. 6 feet long, green, 3 outlets, sold for indoor use through Dollar Tree, Dollar Bill Dollar, and Dollar Express stores nationwide from November of 2005 through May of 2006. The price was $1. The stated hazard: undersized wire and substandard insulation, which can cause overheating. Attached to each cord was a silver counterfeit UL holographic label marked with a file number and the rating 13 amps, 125 volts, 1625 watts. 1 month later, it happened again with a different importer. In September of 2006, Pride Products of Ronkonkoma, New York, recalled about 42,000 cords. Brown or white, 6 to 15 feet long. 3 outlets, sold at discount. Drug and grocery stores nationwide. From June of 2005 through August of 2006. Price: between $1 and $2. The hazard on those: undersized wiring and no fuse in the cord to provide overcurrent protection. Same story on the label. Silver counterfeit holographic sticker, complete with a file number and the identical rating. Now, one thing said plainly: because it matters and because you deserve the accurate version. These were dollar stores, discount chains, drug stores, and grocery stores. This was not the electrical aisle of a national hardware chain where cords come from named manufacturers with addresses and recall obligations. But do not mistake that for distance. Nobody buys their 8th extension cord at a hardware store. The cheap cord is the one that ends up behind the couch, in the garage, under the Christmas tree, running the space heater in the spare room. And note one detail in both notices: no injuries reported. That is not reassurance. Nobody traces a house fire back to the cord that started it. The cord is the first thing to burn. 642,000 cords. 2 recalls, 1 month apart. The same forged sticker on both. If you have made it this far, you are halfway. So far, this has been 1 substitute and 2 recalls. The back half is the record 20 years of the same finding, and the moment the federal agency admitted in writing that the test you would think to run does not work. 20 years. That is the phrase buried in the federal rulemaking file, and it changes what this story is. Start with the border. Commission staff identified 54 separate shipments of extension cords arriving at import, totaling 160,000 units, in which the cords may not have complied with UL 817. 54 shipments. Not one bad container from one bad supplier. Then came the letter. On the 9th of January, 2015, the Office of Compliance wrote to manufacturers, importers, distributors, and retailers of extension cords, stating that products failing the standard's readily observable requirements are defective and present a substantial product hazard. And in explaining why that letter was necessary, the Commission wrote the sentence that reframes this entire subject. In numerous instances over a period of 20 years, staff had found cords missing one or more of the identified characteristics. 20 years of the same finding. That is not an incident. That is a standing condition of the market, documented by the agency responsible for it, in its own filing. Now here is the part that turns out to be useful to you. Faced with that, the Commission built its enforcement around 6 things an inspector can verify by looking: minimum wire size, sufficient strain relief, proper polarization, proper continuity, outlet covers on 2-wire indoor cords, and a proper jacket on anything sold for outdoor use. The term of art is readily observable, and the reason for it is practical. A port inspector facing a pallet of cords cannot run a laboratory. The test has to be fast, cheap, and repeatable by a person with a hand tool, which means something genuinely unusual. The federal enforcement checklist and the checklist available to you standing in a store are the same list, with one exception. There is a 7th thing that matters more than any of them, and it is not on that list because the Commission looked directly at the question of how to detect it and said in writing that it could not be done. The 7th thing is the metal itself. During the rulemaking, somebody proposed the obvious consumer test, the one you were probably already thinking about. Use a magnet. Steel is magnetic and copper is not, so a magnet would catch a steel cord instantly. Free, fast, and anybody can do it at a shelf. The Commission's response is the center of this entire video. Magnets are not attracted to copper or to aluminum, but are attracted to steel. So a magnet can detect steel. It cannot detect aluminum. The magnet catches the cruder fake and misses the common one. Then they addressed the better test. A resistance measurement could distinguish whether a conductor is made of copper, but the high-precision equipment required for a sufficiently accurate measurement is costly, and using it would not be readily observable. Read that as what it is. The federal agency responsible for this product examined the question of how to prove what metal is inside a cord, considered the practical options, and concluded it could not be done by looking. So, conductor material never made it onto the observable list. Wire size did. And that is the crack of daylight in all of this, because those 2 failures travel together. Nobody builds a cord with a substitute conductor and then invests in a full gauge one. Both choices come from the same decision to build under the rating and print the rating anyway. Catching the gauge catches most of it. But sit with the shape of the thing first. A product whose single most important property cannot be verified without laboratory equipment. Sold for $1, under a certification sticker that any print shop can reproduce. In a market where the same finding recurred for 20 years, what exactly was protecting you? 6 things, all of them visible. That is what is left, and it turns out to be more than it sounds. These are the 6. Not a workaround, not a hack. This is the actual federal enforcement checklist, and every item on it is something you can see or feel. 1. Wire size. The Commission's own method is to strip a short length of insulation and measure the bare conductor against a circular wire gauge. 16-gauge wire passes through the 16-gauge slot and will not pass through anything thinner. A wire gauge costs a few dollars and lasts forever. This is the single most useful check on the list, because the substitute conductor and the undersized conductor almost always arrive together. 2. Strain relief. Take the cord where it enters the molded plug and pull firmly. The standard subjects that joint to mechanical pull force during listing. If the jacket shifts or the wire creeps out under ordinary hand pressure, it will not survive one snagged cord dragged across a driveway. 3. Polarization. On a two-blade plug, one blade should be wider than the other, so it can only enter the receptacle one way. That orientation is what keeps a switch on the energized side of the circuit rather than the neutral. 4. Continuity. A $3 receptacle tester plugged into the far end confirms that the connections inside are what the plug claims they are. 5. Outlet covers on two-wire indoor cords. 6. A proper jacket on anything sold for outdoor use. Now the honest limitation, said once. None of these 6 proves what metal is inside. What they prove is whether the manufacturer cared. A company cutting the conductor is not spending money on strain relief. And the heft comparison from earlier has exactly one good use, 2 cords, same gauge, same length, in your 2 hands, in the store. A large difference is a signal worth acting on. Before you close this, here is the one rule worth keeping. Buy the 6 characteristics, not the hologram. A sticker is a claim. A wire gauge is a measurement. Where you buy matters more than it should. A cord from a national retailer's electrical aisle, made by a company with an address and a recall obligation, is a fundamentally different risk than a dollar store cord or a marketplace listing with no manufacturer name attached. Every counterfeit in the federal record came through discount and dollar channels, and the certification mark can be verified. That file number on the label corresponds to a real record held by the testing laboratory. If the number does not resolve to the company printed on the packaging, the label is decoration. Then there is the rule that costs nothing at all. Match the cord to the appliance, not the appliance to the cord. Space heaters, window air conditioners, and compressors are exactly where a marginal conductor turns into a fire, and they are exactly where the cheapest cord in the house tends to end up. One habit worth building. Run your hand along a cord under load. Warm at the plug is a connection problem. Warm along the whole length is a conductor problem, and you should stop using it. Now the answer to the question this started with. Nobody voted to stop using copper. Nobody quietly amended a standard. Copper is required today exactly as it was required 30 years ago. What changed is that a holographic sticker became easy to print, and a global supply chain became easy to enter. The requirement stayed where it was. The enforcement thinned out underneath it, which means the last inspection that cord will ever receive is the one you give it in the store. If this changed how you look at that drawer full of cords, send it to whoever has a space heater running on the cheapest one in the house.